Welcome to Tech Talk with Beanie.
When people think of advanced technology, they usually imagine computers, rockets, satellites, or artificial intelligence. They imagine the modern world. But if you really step back and take a look at history, some of the most impressive technological civilizations ever built existed thousands of years ago. And the two of the most greatest examples are the ancient Greeks and the ancient Romans. What makes them so fascinating is that they were not advanced in the way we are advanced today. They did not have electricity, microchips, combustion engines, or digital communication. But what they did have was something just as important: deep observation, mathematical reasoning, practical engineering, and an incredible ability to solve real-world problems using the materials and knowledge they had. In many ways, the Greeks and Romans created the technological foundation of Western civilization. The ancient Greeks were masters of theory, mathematics, mechanics, and scientific curiosity. The Romans were masters of scale, infrastructure, logistics, and applied engineering. Together, they formed one of the most technologically impressive periods in human history. Ancient Greece was not one unified empire for most of its early history, but its city-states produced some of the most influential thinkers and inventors the world has ever seen. The Greeks were obsessed with understanding how the universe worked. That curiosity drove advances in geometry, astronomy, mechanics, medicine, and engineering. One of the biggest reasons Greek technology was so impressive was because it was tied directly to mathematics. Greek thinkers like Euclid, Archimedes, and Pythagoras were not just doing abstract philosophy, they were creating the mathematical language that made future engineering possible. Geometry, ratios, leverage, and volume were not just concepts to them, they were tools. Archimedes in particular stands out as one of the most brilliant technological minds of the ancient world. He studied buoyancy, pulleys, levers, and war machines. He famously said that with a long enough lever and a place to stand, he could move the world. That was not just poetic language, it reflected a deep understanding of mechanical advantage. He understood that force could be multiplied through tools. That idea is basic to engineering today, but in his time it was revolutionary. The Greeks also developed sophisticated machines powered by water and air. One famous example is the Archimedean screw, a device used to move water uphill. It consisted of a helical surface inside a cylinder, and as it turned, water was lifted upward. Then there is the antiquity mechanism, one of the most astonishing artifacts ever discovered from the ancient world. Found in a shipwreck, this device was essentially an analog computer. It used a system of bronze gears to predict astronomical positions, eclipses, and calendar cycles. Think about it. More than 2,000 years ago, Greek engineers created a precision gear-driven machine that could model celestial movements. That is not primitive technology. That is highly advanced mechanical computation. Greek engineers also experimented with automation. Hero of Alexandria described devices powered by steam, compressed air, and water pressure. He designed temple doors that could open automatically, mechanical puppets, coin-operated machines, and primitive steam-powered devices. One of his inventions, the olipile, is often described as an early steam engine. It did not power factories like the steam engines of the Industrial Revolution, but it showed that the Greeks understood how expanding steam could create motion. Greek medicine was also remarkably advanced. Hippocrates helped move medicine away from superstition and toward observation and diagnosis. Greek physicians studied anatomy, symptoms, diet, and environmental causes of illness. Their understanding was not modern, of course, but it represented a major technological shift in how humans approach the body, through systematic investigation rather than pure myth. Greek architecture was another form of advanced technology. Builders used mathematical proportions, load-bearing stone design, and subtle visual corrections to make structures appear perfectly balanced. The Parthenon, for example, includes refinements like slight curvature and column adjustments that compensate for optical illusions. That means Greek builders were combining aesthetics, geometry, and structural engineering at a very high level. Now let's move on to the Romans, because if the Greeks mastered the science behind technology, the Romans mastered the large-scale implementation of it. Roman civilization was built on engineering. Their genius was not just invention, it was systems design. The Romans took ideas, materials, and methods, then organized them into massive, durable, empire-wide infrastructure. Roads, aqueducts, harbors, bath complexes, sewers, bridges, fortifications, and concrete megastructures. This was all a civilization that thought like a giant operating system. One of the greatest Roman technological achievements was their road network. Roman roads were not simple dirt paths. They were carefully engineered transportation systems with foundations, multiple layers of materials, drainage, grading, and durable stone interfaces. These roads allowed troops, trade, messages, and administration to pass rapidly through vast distances. In technological terms, Roman roads were the empire's data network. They connected everything. Then there were the aqueducts. These were some of the most impressive hydraulic systems in pre-modern history. Romans transported water over long distances using gravity-fed channels engineered with precise gradients. The slopes had to be accurate enough to keep water moving steadily without eroding the structure or stagnating. Aqueducts supplied cities with drinking water, public fountains, baths, and even industrial uses like mining or milling. What makes Roman aqueducts so impressive is not just that they worked, it's the precision required to design and maintain them over miles of terrain, sometimes using tunnels, bridges, and siphon systems. This required surveying skill, materials knowledge, and an advanced understanding of civil engineering. Roman concrete is another extraordinary example. Unlike many ancient building materials, Roman concrete has proven unbelievably durable. It allowed the Romans to construct harbors, domes, vaults, and large public structures on a scale that would have been very difficult with cut stone alone. The Pantheon, with its massive, unreinforced concrete dome, is still one of the greatest engineering achievements in history. The Romans understood how to use volcanic ash and lime to make concrete that would harden effectively and endure for centuries. And that is not just with buildings. Roman harbors used concrete in marine environments. Some Roman underwater structures survived for millennia, and that's an astonishing material science accomplishment. Roman military technology was also highly advanced, not because of flashy superweapons, but because of disciplined engineering and standardization. Roman armies built roads, bridges, camps, siege ramps, and fortifications with incredible speed. Their logistics were technological. Their organization was technological. Their standard equipment and modular methods allowed them to expand and maintain control over huge territories. Their siege technology included catapults, battering rams, towers, and defensive works. These were based on principles of torsion, tension, leverage, and force transfer. The Romans may not have invented every device they used, but they perfected deployment, scale, and integration. Roman cities were also remarkably sophisticated. Many had sewer systems, public baths, heating systems, and planned layouts. The hypocaust system, for example, was a form of underfloor heating. Hot air from a furnace circulated beneath floors and through wall spaces to warm buildings. That is a very advanced thermal engineering solution for an ancient world. Public bathhouses themselves were technological marvels. They required water supply, drainage, heating control, and architectural planning for large populations. These were not just places to wash. They were integrated, engineered environments. The Romans also used water-powered industry. Water mills ground grain and supported food production on a large scale. This matters because it shows ancient technology was not just limited to monuments and war. It also supported everyday economic life. So who was more advanced, the Greeks or the Romans? The truth is that they were advanced in different ways. The Greeks pushed the boundaries of scientific thought, mathematics, and mechanical concepts. They asked foundational questions about physics, astronomy, and engineering. They were the great theorists and experimenters. The Romans, on the other hand, excelled at execution. They built systems that could serve millions of people across enormous territories. They were masters of practical engineering, infrastructure, and durability. The Greeks gave the world many of the principles. The Roman gave the world many of its applications. And this is why both civilizations matter so much to technological history. Modern engineering did not appear out of nowhere. It grew from earlier traditions of geometry, mechanics, hydraulics, architecture, and material science. The infrastructural roots of civil engineering owe a huge debt to Rome. What is especially humbling is that these civilizations achieved so much with such limited tools. In fact, one of the best ways to measure true technological sophistication is not by asking whether a civilization had modern tools, but by asking how effectively it used the knowledge, resources, and physical laws available to it. By that standard, the Greeks and Romans were extraordinary. So the next time someone talks about ancient civilizations as if they were simple or primitive, remember this. The ancient Greeks built mechanisms that functioned like analog computers, and the Romans built infrastructure networks that powered an empire. That's not just history, that is engineering greatness. Alright, like that. Ready? What did I say? What did I say? Oh, what? Can I read this and it's down there? Alright. In many ways, the Greeks and Romans created the technological Technological. No, but that's how I do that. I make up stuff. Ancient Greece was not one of the... Okay, let me read this. Oh, hold on. Is that how you really say it? Greek engineers also experimented to... Okay. How do you say that? It sounds like a pasta dish. Am I gonna get butchered online for this? They were engineered with... They were engineered with... Don't be putting that in there. Don't be putting that in there. I'll get canceled. I'll lose my job. Subtle. Roman roads. The actual... Ballistier?
Thanks for watching. I'll see you next time.